We have here a unit circle, which is essential to know and understand, particularly when you get into your pre-calculus class, and of course, moving forward from there. So I am going to show you how to fill in the unit circle in a very easy way that you don't have to necessarily memorize it, but you can understand how it's created. And so therefore, if you happen to forget a value, then you can generate it very quickly and recall it. But of course, after you use it over and over again, you tend to just kind of memorize the values. So what I have here already is you can see all of the degrees are in place. And remember, a unit circle means a radius of 1. So the distance from here to here, which is the radius, is going to be 1 unit. So that's why it's called a unit circle. So let's start by going over the radian measures. So the radian measures are going to go in all of these blanks that you see going around the circle. So I already have the degrees filled in. We're going to fill in the radian measures. So one thing that you definitely need to know is that if you go, we know the circumference of a circle is 2 pi r. But in this case, since we said it's a unit circle, we know r equals 1. So the circumference of the circle is 2 pi. We also know that if you do one full loop around the circle, you get 360 degrees. So 2 pi is equivalent to 360 degrees on a unit circle, which means dividing by 2, we know pi is going to be the same as 180. So you can use that conversion anytime if you need to convert any type of radian measure or degree measure back to one or the other. So we're going to start here. If we know that you go all the way around, it's 2 pi, we're going to go ahead and fill in the radian measures. So filling in the radian measures, we're going to start at 0 radians. And if we go all the way around, we said it's 2 pi radians. And if we go to 180 degrees, we know we are at pi radians. Now, the next ones that you want to fill in are the ones that are going to be halfway between those two. So halfway between 0 and pi would be taking pi and dividing it in half, so it'd be pi over 2. So this distance would be pi over 2, which is 90 degrees. And so now if we know this is pi over 2, then this is going to be 2 pi over 2. But you can simplify 2 pi over 2 to just be pi. So if we go around another distance the same, this will be 3 pi over 2. So down here at the bottom where you see 270 degrees, that's going to be 3 pi over 2. And then of course, if you went another distance, you would be at 4 pi over 2. But we know 4 pi over 2 is the same as 2 pi, which puts us there. So essentially what you can see that I'm doing is I'm counting in fractions, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. And so then you can easily fill those in. And all I really had to remember was this or this, right? The circumference of a circle. So that's going to take care of the ones on the quadrants, right here and here. Okay, so now we can go and fill in the others. So the next thing that I recommend doing is all of your 45-degree angles, because all of your 45-degree angles are just going to be dividing that same distance that we just did, dividing that into a half. So for example, right, if you have this distance from 0 to pi over 2, and you take half of that, well, pi over 2 times a half is going to give you pi over 4. So now we know this distance right here, or this measure in radians, is going to be pi over 4. So from here to here is pi over 4. So just to make those stand out a little bit more, I'm going to make them all blue because there are quite a few lines here. Okay, so maybe that's sufficient enough. So all of those in blue are going to be your pi over 4s, but see, we also had the distance from here to here that we considered as well, because we know that's cut in half. So I'm going to also make those stand out. And so we'll make the axes, we'll make those orange because we've already talked about those. Okay, so now you're just looking at the blue and the orange. So from here to here is 1 pi over 4. But if we go here to here, we're at 2 pi over 4. But we know 2 pi over 4 simplifies to pi over 2. But you can keep counting in this manner. So this is 3 pi over 4. So we're going to label the coordinates for this one to be 3. Let me make that a little smaller. 3 pi over 4. And then we have 4 pi over 4 is just pi. And then 5 pi over 4 would be the next one. And then 6 pi over 4 would simplify down to that. And then from here to here would be 7 pi over 4. And then finally, you're going to end up here to here, and it's 8 pi over 4, which once again is another way to simplify down to 2 pi. Okay, so now you have all of your pi over 4 multiples, and you have all the ones that are actually on the axes. So the next one we're going to look at is our 30s and then our 60s, but I'm going to make those different colors as well because we know eventually they're going to have different reference angles. So what you're going to do to figure out how to label that in terms of radians is 30 degrees is if you go all the way around, you're really taking pi, and we're now looking at the white and the orange, so you're going to ignore the blue. So if you do the white and the orange, you can see that you're dividing pi into 6 pieces, right? From here to here, from here to here, here to here, and like that. Okay, so there's your 6 pieces that you're dividing it into. So we're going to take pi, and if you divide it into 6 pieces, it's going to be pi over 6. So that means 30 degrees is going to be equivalent to pi over 6. So let's make all of those stand out by, now I'm making just these ones pink because these ones are going to have the same reference angle. So if we haven't done that yet, you'll see why I'm doing it eventually. But then when you go up to the 60 degrees, you see if this is 1 pi over 6 from here to here, then from here to here would be 2 pi over 6. But 2 pi over 6 is going to simplify down to pi over 3. So we're going to call that one pi over 3. So this will be pi over 3. And then I'm going to make all of those ones that are multiples of pi over 3. We're going to make those green. So it's going to look nice and colorful, easy for the eye to identify. Okay, when we're all done. But we have to fill in the rest of all of the radian measures. So to do that, since these are all the same distance, they're all pi over 6, we can just count by pi over 6. So we already did this one. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, which is just pi over 2. So this is 4 pi over 6, but 4 pi over 6 is simplified to 2 pi over 3. So in this spot, we're going to mark 2 pi over 3 radians. keep going. So that's 4 pi over 6, 5 pi over 6. So 5 pi over 6 is going to go right here. And then go into pi, we'll give you 6 pi over 6, which simplifies to pi. And then once again, we're at 7 pi over 6. So let's see, I moved that in the wrong spot. So we'll just see if we could move this one down there. And I'll move that up there. Okay. Good enough. Okay, so this is going to be 7 pi over 6. All right, so keep going. We have 8 pi over 6. 8 pi over 6 is 4 pi over 3. So we're going to put 4 pi over 3 right here. Then we were at 8, so this is 9 pi over 6, which simplifies down to this. And then 10 pi over 6. 10 pi over 6 is going to be 5 pi over 3. And then finally, that's 11 pi over 6, and that should be the last one because 12 pi over 6 puts you back around to 2 pi. So that's how you fill in all of the radian measures. Now, to fill in all of the values for the coordinates, okay, we use, well, the simple ones would be all of the orange ones because they're already sitting on the axis, right? So if this is the origin and we know this distance is 1 all the way around, then we can quickly and easily fill in all of these coordinates. So this is going to be 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. Now, the other ones, really, you just have to learn these three because everything else is going to be just a reflection, right? So let's label our quadrants. So over here, you're in quadrant 1. This is in quadrant 2. Down here, you're in quadrant 3. And then over here, you're in quadrant 4. So we know that if you're in quadrant 1, that both x and y are positive. So we can say over here that you're positive, positive. And in quadrant 2, x is going to be negative, but y will be positive. In quadrant 3, both x and y are negative. And then in quadrant 4, x is positive, y is negative. So if we keep that in mind, and we know these are in the same location, for example, if you're looking at the pink ones, all the pi over 6s are going to have the same coordinates, but you're just going to change the sign depending on which quadrant they're in. So for example, and we'll go over in another video why the coordinates are what they are, but this comes from a 30, 60, 90 triangle that's here. So if you have a 30, 60, 90 triangle, we know that the x coordinate and the y coordinate when you're in the unit circle are representing the cosine and sine values. So this value is always going to be a 1/2. And this one is going to be square root of 3 over 2. And so if we're just looking at those coordinates, if you reflect it over here, the only thing that changes is that the x coordinate's going to become negative. So this will be minus square root of 3 over 2, 1/2. If you reflect it down here, then the x stays the same, but y would turn negative. So this one would keep the minus square root of 3 over 2, but then a minus 1/2. And then once again, if you reflect it over here, you have a now positive x, but still negative y. So positive square root 3 over 2, negative 1/2. And then you can do it the same way. Now the pi over 3, because this is also a 30, 60, 90 triangle, but the angles are switched, these just switch. So this is going to be your 1/2 and square root of 3 over 2. And then we can just fill these in quicker. because this is negative, positive. Down here, you're both negative. And over here, you're positive, negative. And then you have your pi over 4s. This comes from a 45, 45, 90 triangle, which we also go over in a different video. So this is going to be square root of 2 over 2 when you rationalize the denominator. And so these ones are easier because the x and the y are the same. So when we reflect them, you just have to watch the signs. And then finally, this one. Okay, and so that completes your unit circle. And so if you really understand kind of the first quadrant here, you can figure out all of these. And then also knowing how all of the radian measures, you can count if you happen to forget. But once you get really seasoned with it, you'll just remember it naturally as you do your work. So look at the other videos where you can learn about how to do the triangles. And so then you can understand why the coordinates are what they are for each of those. And we'll see you there.